Good morning, students. Welcome to our learning platform channel of mathematics. So, in previous videos, we covered how to find determinant of a square matrix, adjoint of a square matrix, because these two are very important to compute inverse of the square matrix capital A, or the multiplicative inverse of the square matrix capital A. And what is the condition to find out A inverse? The determinant of that matrix should not be 0. Should not be 0. So, under matrices, topic 2, operations on matrices, it is continued. Here we discuss how to compute compute A inverse, and this one is always a square matrix, always must be a square matrix. Condition, the foremost condition to compute A inverse, det A cannot be 0. You can write this one as det of that square matrix, you should not get 0. Note point, if any square matrix satisfying this property, that matrix is called non-singular matrix. If det A equals 0, where A is a square matrix, then A is called a non-singular matrix. If it is equal to 0, it is called singular matrices. So for non-singular matrices only, we are going to compute A inverse. Let us continue. To compute A inverse, right? First one, the determinant of that matrix cannot be 0. Second one, once you get this condition, then only you have to go for second one. Compute, as I explained, adjoint of that matrix. In third stage, A inverse is given by 1 by the value whatever you got det. Because division is not defined, that's why it should not be 0. Make sure that this matrix A is a square always. A square matrix only. 1 by det A into whatever the adjoint matrix you got. Just you have to multiply. It's a pure number, it's a matrix. So this is the way to find out A inverse or the multiplicative inverse, the third stage. Let us work out a problem based on these three steps. Let us consider an example. Let capital A is equal to 1, 1, 2, 3, 0, 1, 1, 4, 1. I took a square matrix of size 3 by 3. So first, if you want to compute inverse of this matrix, you should show that det A is not equal to 0. First one, compute, or we can write check determinant of that matrix is not equal to 0. Compulsory condition. So I already gave you the method to find out det A. In previous video, I read the formula directly. You can take any row or column of your choice, but don't take diagonal elements. That indicate R1, R2, R3. Sorry, it is column number. R1, R2, R3. Row 1, row 2, row 3. So let us take row 1. When you select row 1, these elements you can denote them by their original representation. It is A11, A12, A13. So I'm selecting row 1, circled 1. So these are elements A11, A12, A13. For the formula I gave you that day, it is A11 into its minor. Alternatively, we can write the sign A12 into its minor plus A13 into its minor. A11, it is 1. This already you know how to compute. Deleting first row, first column, we get 0, 1, 4, 1. First row, first column. On removing them, we get 0, 1, 4, 1 minus A12 is 1 again. Delete first row, second column to get the minor. First row, second column, we get the leftover elements are 3, 1, 1, 1 plus A13 is 2. Delete first row, third column. First row, third column, 3, 0, 1, 4. So simplification part 1, this value will be LDP minus RDP rule again. 0 minus 4, negative 4 minus 1, 3 minus 1, it is 2 plus 2 into 12 minus 0, it is 12. Further simplification, negative 4, negative 2, minus 24. This comes out to be negative 6 minus 24, that is negative 30. So it is clearly not equal to 0. You may get a positive number or negative number but not 0. First condition is fulfilled. Let us continue. The second stage is computing adjoint of the square matrix A, this matrix only. Here I am going to choose the shortcut method to compute adjoint of capital A. Here I indicated row 1, row 2, row 3, C1, C2, C3 in red color so that I can copy the same matrix elements there in blue color. 1, 1, 2, 1, 1, 2. 1 is there, it is typed off actually. 1, 1, 2, 3, 0, 1, 3, 0, 1, 1, 4, 1, 1, 4, 1. Then what is the technique we followed there? We have to copy R1 and R2. I indicated in green color. So R1 1, 1, 2, 1, 1, 2. R2 3, 0, 1, 3, 0, 1. Similarly, after C3, copy C1 and C2 of this one, column 1. 1, 3, 1, 1, 3. 1, 3, 1, 1, 3. C2 1, 0, 4, 1, 0. 1, 0, 4, 1, 0. Then delete the first row and first column elements. They are not to be considered. Now, with the help of that LDP minus RDP rule for row wise, if you select, we have to write down that elements column wise. So, first direction, first stage, second stage, third stage. We compute elements by applying LDP minus RDP rule by taking four elements. 3 elements we are going to get here row wise, but those elements we are going to write down column wise in our adjoint A. Stage 1, stage 2, stage 3. So total we get 9 elements. So here it is ready, the adjoint of the square matrix. As I told you, how you got these elements. This direction, take this 4, 0, minus 4, negative 4. Write column wise. Compute like this, write column wise. Next, 1 minus 3, negative 2. 12 minus 0, 12. Over this direction, 8 minus 1, 7. 1 minus 2, negative 1. 1 minus 4, negative 3. second column, last. 1 minus 0, 1. 6 minus 1, 5. 0 minus 1, 0 minus 3, 3. So I give the formula to calculate adjoint of the square matrix. It is equal to 1 by det A into adjoint A. 1 by minus 30. Adjoint A, the copy the matrix as it is. You can leave at this stage, or you can take this element and multiply every element inside that matrix. You can show like that also more accurately after simplification like this. Hope it is clear to you. Let us write the last step. If you wish to write only in matrix elements without showing that outside scalar or real number. So hence by taking that inside, minus minus plus 4 by 30, it is 2 over 15. Simplest form. Negative 7 by 30. Negative 1 by 30. 1 by 15. 1 by 30. 1 by 6. Negative 1 by 6. 4 by 10. 12 and 30. 6 twos, 6 fives, minus 2 by 5. Plus 1 by 10. Plus 1 by 10. So this is your required inverse of A. Like this, you can able to compute inverse of a given square matrix. First, check the determinant of that square matrix is not equal to 0. That means the matrix A should be non-singular. Then compute the adjoint of that matrix by using shortcut method or the other method what I explained. To compute A inverse, don't forget it's 1 by det A into adjoint A. Hope this lecture is clear to you to find the A inverse. In next video, we are going to start topic 3 called elementary matrices. Do share our channel and inform your friends about the concept, how you are able to learn. Because slow learning in concepts, you can perform well in your examinations. God bless you all. Thank you.